The method environment has to be added to all the other type rules in our system. This is really easy to do because only the dispatch rules actually care about what the methods are. All the rest of the rules just pass the method environment along. So what do I mean by that? Well, here's our rule for add with just the object environment. So now what we're going to do is we're going to add a method environment, and the sub-expressions will be just type checked in exactly the same method environment as the entire expression. And all the other rules simply pass down the method environment from the root towards the leaves without changing it, just as in this rule. Now it turns out that for some cases involving self-type, we actually need one more thing in our environment. And so the actual full environment for cool type checking consists of three things. First of all, there's the mapping O that gives types to object IDs. There's this mapping M that gives types to methods. And finally, we just need to know the name of the current class. So whatever class the expression we're type checking actually sits in. So the full form of a sentence in the cool type checking logic looks like this, and is read as follows: under the assumption that the object identifiers have the types given by O, that the methods have the signatures given by M, and that the expression sits in the class C, then we can prove that the expression E has the type T. And here's an example, the add example, the rule for addition again, written out with the full environment. So the rules that I've given you for type checking here are cool specific, and some other languages have very different rules. But there are some general themes of type checking. First of all, type rules are defined on the structure of expressions. So they're typically done in this inductive fashion, where the types of an expression, the type of an expression depends on the types of its sub-expressions. And also the types of variables, and more generally any free names in an expression, things like method names, they're going to be modeled by an environment. So we're going to have some mapping sitting around that tells us for any kind of free name in an expression what assumptions the type rules should make about the types of those names. And one thing you've probably noticed by now, but it's worth saying explicitly, is that type rules are really very compact. The notation is not complicated, but there's actually a lot of information in these rules, and you have to take some time to sit and read them carefully to really understand what they are saying.